Okay, so we're going to start with limits. This is actually Unit 1-1, and this is an intuitive approach. And what we're going to focus on is our function f of x right here in this graph. Okay, so this is f of x. And what the definition says is that if the values of f of x can be made as close to, if not almost equal to, some given value L, which is really the y value once we plug in whatever our x value is to the function. So we're just going to call this f of a. By taking values of x sufficiently close to, but not equal to, some given value a, okay, then we would write the following: the limit as x approaches a of f of x is equal to L. Okay, so we are getting close to a given value, but not equal to. So what happens here is that if this is our function, okay, and we have some given value a that we want to plug into the function, okay, what we're looking at is the behavior of the function as our x value approaches that a value from the left and from the right, getting really, really close to, okay, this given L value, okay? All right, and what we're looking at is we are going from the left to the right, okay? So from the left to the right, all right? This is what this is talking about. And as I said before, this is read as the limit of f of x as x approaches a is equal to L, or it could also be read as f of x approaches L as x approaches a. So there's lots of different ways that you can state this. It just depends on your preference. So what we're going to focus on first is just a general definition. What we'll focus on first is a one-sided limit. Okay, and that's technically how you're going to be looking at this. You're approaching from one side and from the other side when you evaluate the overall limit. Okay, so that's why we're going to focus first on the one-sided limit. So if the values of f of x can be made as close to, or as close as we like, to L, okay, by taking the values of x sufficiently close to a, but not equal to a, okay, and what we need to focus on is that they are greater than a, then we're going to write the following: the limit of f of x, okay, is going to be equal to L, but what we're looking at in this case is as x approaches a from the right, that little plus right there, okay, and it says the limit of f of x as x approaches a from the right is equal to L. Okay, so this is the limit of f of x as x approaches a from the right, okay, and that's what this plus means here, from the right, right, and it's equal to L. Now what you have to consider is we are only looking at the limit from the right in this case. Now on the other side, what we can say is if the values of f of x can be made as close as we like to L by taking all values of x sufficiently close to a but less than a, then we're going to write the following: the limit of f of x is equal to L as x approaches a from the left, with that little subtraction sign as the exponent. So again, we're saying the limit of f of x as x approaches a from the left is equal to L. All right, so these two are definitions, and this right here is from the left. Okay. So now what we're going to do is we're going to take a look at a few examples, and we're going to use this graph right here. So what we're looking at is, in each case, we're looking at the one-sided limits. Okay. So here it says evaluate the limit as x approaches -2, and this minus up here as an exponent is from the left of f of x. So So we're going to go to where x is negative 2, and you look. Here, you are coming from the right. Here, you are coming from the left. And if you notice, both of these values are different, so it's important that you choose the correct one. Here, we're approaching from the left, and that means this y value right here is equal to 1. Okay, so in B, we're going to evaluate the limit as x approaches negative 2 from the right. So you notice here, this is an open circle. Doesn't matter. We're evaluating or looking at the behavior as x is approaching a given value. It doesn't matter if it's equal to. Okay, that's irrelevant. We're looking at the behavior of the function. So in this case, this value would be 0. So now we're looking at the limit as x approaches 0 from the left. So here, 0 from the left is 1. Again, they're asking us to evaluate the limit of this given function as x approaches 0 from the right. It's also 1. Okay, so what I want you to do right now is take a look at these limits. I'm going to pause, okay, and then you'll come back and check your answers. Okay, so here you have the limit as x approaches 2 from the left. So 2 from the left is 0, 2 from the right is 3. This here, a couple different answers probably would be accepted because we're looking at the value of the limit as x approaches 4 from the left and from the right. And it is a little bit ambiguous here, so if I were to draw a dotted line up this way and come across this way to see what the appropriate y value would be, it's approximately 3.5, so that would be an approximate value. Okay, so with the idea of a one-sided limit, we can then evaluate a two-sided limit. So I'm going to cover the definitions, and then this way, if you understand a one-sided limit, you should understand the two-sided limit. Okay, so here we have the definition of a two-sided limit. Okay, so if f of x, if the limit as x approaches a from the left of f of x and the limit as x approaches a from the right of f of x both exist and are the same value L, okay, then the limit overall, meaning the limit as x approaches a from both the left and the right, that means the graph is coming together, and the limit exists, therefore it's equal to L. So if they both exist and are the same number L. Okay? So there is a small caveat. If either one-sided limit does not exist, okay, does not exist, or they both exist but are the same numbers, then the limit as x approaches a of f of x does not exist. Okay? The limit does not exist. Okay? And we use the abbreviation DNE for does not exist. Okay? And there are a lot of different ways that a limit won't exist, and we're going to cover those. Okay, so here, if the limit as x approaches a of f of x is equal to L, then both the one-sided limits exist and are equal to L. Okay, so here it's saying there are a couple different ways that the limit itself cannot exist, and we're going to cover that as we continue this lesson.